Hi, I'm Miro from GetIntoDevOps.com. In this first ever episode of the DevOps Clinic, we'll be discussing continuous delivery, doing a very quick hands-on guide on setting up jobs in Jenkins 2, and looking at how to grow EBS volumes on AWS EC2. Welcome to the DevOps Clinic. First, we'll talk about continuous delivery. James sent me a question stating, does everyone want to do continuous delivery? I think that's an interesting question, and it really goes down into the definition of continuous delivery. Continuous delivery is the art of shipping smaller increments of change faster, and in practice ensuring that whatever you have in a shared branch of your code repository is deployable to production at any given time. This implies that you have automated testing in place to catch any faults as early as possible. In a way, you can think of continuous delivery as the art of rejecting any changes that could break your production environment before they do. One of the requirements for continuous delivery is a repeatable deployment process, but there are many things that affect the reliability of a continuous delivery pipeline. One example is the environment setup. If the testing environments are not identical to the production environment, there's no confidence that a change that works in testing would actually work in production. Continuous delivery does not mean that every change you do would be pushed to production automatically, but merely the confidence that deployment, whenever you'd want to do it, is repeatable and simple and effortless. The last mile, if you will, the act of automatically deploying every change into production is often called continuous deployment. And this is where the distinction comes. In my view, everyone will want to do continuous delivery. Everyone wants to ship changes as fast as possible, but someone might not want to do continuous deployment. Some of the reasons you might not want to do continuous deployment could be, for example, legal reasons, or maybe you just need business stakeholder sign-off before making any changes live in production. These are things that can be hard for you to change as an engineer, but actually from a technical point of view, there is something you can do, and that's feature toggles. To put simply, a feature toggle means wrapping any new functionality you write inside a conditional block, which will enable you to turn that piece of functionality on or off at runtime, usually per environment. This will enable you to ship changes when they're development ready and test them in your testing environments and turn them on in production at a later stage. With feature toggles, you will be able to do a full end-to-end continuous deployment pipeline, shipping all changes all the way to production as they are ready, but ensuring that every change can be turned on or off in different environments as need be. Our second question for today is from Ali, and it reads, what's the best way to configure jobs in Jenkins? There's a remarkably easy answer to this, and it is Jenkinsfiles. What's a Jenkinsfile, you ask? Let's take a look. A Jenkins file defines the build pipeline of your application in a Jenkins-specific language. There are two different syntaxes for a Jenkins file. One is the declarative pipeline and the other one is the scripted pipeline. The example we see here is the scripted pipeline. You can download this Jenkins file along with the simple application it builds by visiting GetIntoDevOps.com/code. The benefit of using a Jenkins file to define your continuous delivery pipeline is that it is stored in version control along with the code it's building. This allows the Jenkins file to be versioned with your code, so any changes to the continuous delivery pipeline can be traced back in version control just as any other code change. In this particular Jenkins file, we are using the Jenkins Docker pipeline plugin to build a Docker image out of our application. Let's look at the stages we define. In the first stage, we will clone the repository. The checkout SCM command is a shortcut telling Jenkins to clone the same branch this Jenkins file was obtained from into the workspace. In the second stage, we tell the Docker pipeline plugin to build our Docker image. This is just the same as calling docker build on the command line. In the third stage, we have a placeholder for tests. As you can see, we're only echoing the string tests passed here. The interesting thing to note though is that we're doing this in an app.inside block. This tells Jenkins to execute all commands in this block inside a container of the image we just built. If our image contained, for example, a test framework, we could trigger it at this stage. Another approach for testing could be to run, for example, a Selenium standalone container alongside the image we just built, and run a bunch of automated end-to-end tests against our application. I think that's pretty cool. The fourth and final stage concludes our pipeline. we're pushing the image we just built into a Docker Hub registry with credentials that we have defined as Jenkins credentials. This avoids us having to push credentials into the code repository, which is always a bad idea. As you can see, we're pushing the image twice, first with the build number and then with the latest tag. Pushing the same image multiple times is cheap because all the file system layers are reused. In this particular example, we're building a Docker image, but we could just as well invoke maven or make or a bunch of bash scripts to build and deploy a different kind of application. And by all means, you are not limited to 4 stages or these particular stages. Just make sure that the first stage has the checkout SCM command in it to ensure that the workspace has a copy of your code in it. So, let's take a look at how we'll make Jenkins build a pipeline out of this Jenkins file. After logging into Jenkins, the first thing we'll do is add credentials. We'll need 2 sets of credentials, first to clone our code repository and second to push our Docker image into Docker Hub. For GitHub, I'm using a personal access token, which enables Jenkins to use the GitHub API with my credentials while I have the 2-factor authentication enabled. The second credentials we add are for Docker Hub. The important thing to note is that the ID we add here must be the same we reference to in the Jenkins file. Then let's create the actual job. For the job type, we will use a multi-branch pipeline. This is a special job type that automatically creates a separate pipeline for all the branches in our repository. This will allow us to build an image from every feature branch. If we wanted to do different things for different branches, we could write the logic inside the Jenkins file. The only thing we need to define in the job configuration itself is where to find our Jenkins file. As our code sits in GitHub, we will just need to give Jenkins the name of the GitHub owner and select the repository. As we can see, the build configuration is set to use Jenkinsfile by default. First, Jenkins will scan the list of branches in our repository and select the ones that have a Jenkins file in them. In this particular repository, we only have the master branch and Jenkins has now created a job for it. By looking at the console log, we can see that the job is well underway. In fact, Jenkins is already pushing the image into Docker Hub. The console log shows us output from all the stages we defined in the Jenkins file. By looking at the branch view, we can see a summary of the stages we defined. As we can see, Jenkins was rather quick building our pipeline. Finally, in the topmost job view, we can see the list of branches and their build statuses. The final question for this episode is from Lou, and it reads, how to grow EBS volumes in AWS EC2. The ability to dynamically modify EBS volumes was introduced to the public just a couple of months ago, and I think that's really the feature that brings elasticity into elastic block storage. Let's take a look how it works in practice. We have a problem on our imaginary Jenkins server. When we check the disk space usage of mounted file systems with the df command, we can see that the data volume is nearly full. As you might know, Docker images tend to take a lot of space. Luckily, we are running an ext4 file system that can be grown on the fly. Let's go to the AWS console to increase the size of the volume. First, we'll need to find the correct volume. We can find this by looking at the instance. The device name in Ubuntu is xvdb, which translates to SDP in the AWS console. We'll need to select the volume and click Modify. After setting the new size, we'll need to check the volume state. When it says optimizing, the change is in effect. Now we can go back to the instance and resize our partition and file system. For resizing our partition, we will use the parted command. In parted, use the command P to print the list of partitions. Then use the resize part command to resize the partition. After we've grown the partition, we will need to grow the file system in it. This is easy with the resize2fs command. As you can see, we have just doubled the size of our data volume with zero downtime, and it only took us a couple of minutes. Thanks very much for watching the DevOps Clinic. If you have a question you'd like me to cover, please do send it in by visiting getintodevops.com/clinic. In the next episode, we'll be discussing, among other things, how to break into a DevOps career. See you soon.